I'm going to talk you through this watering system. It's an irrigation system which centers around a water butt which has a height. It has rain coming into the water butt, which is controlled by this on-off switch. It also has a pump, and when the pump is on, it reduces the water height in the water butt to a minimum value of 0. And rather than us controlling the pump manually, it's controlled by a state controller. So the state controller is running certain logic. The input to the state controller is whether the soil is wet or not, and the height of the water in the water butt. So when the soil is not wet, when it's dry, that goes into the state controller. It then triggers it to say, well, okay, let's turn on the pump, but first let's check that there is actually water in the water butt. So it goes through a sequence of events which says, okay, if the soil is not wet and if the water butt is enough, then turn on the pump. While the pump's turned on, it might reduce the height in the water butt, so we have the water butt height coming here. If the water butt height is too low, then it comes on with a height warning here. And there's a display which will either be a 0 or a 1. So a 1 means height warning, but it'll highlight in here as well. So that's the basic use of it. We can control rain, switch rain on and off. We can control soil wetness, so does it appear damp or not, which would be really a sensor in reality, and that feeds into the state system here. So if we have a look at the state diagram, if we open this up, what we've got is several states. The first state that it comes into is called read soil moisture. So this might represent where the moisture of the soil is actually read using a sensor, but we're going to take manual control of that with a value here which is called soil wet. So if soil wet is false, so if the soil is actually dry, then it checks the height of the water in the water butt. If the height is fine, if it's bigger than, let's say 10 meters, then it will turn the pump on. So pump is equal to 1, so that turns the pump on. That's the output from the state diagram. And it takes away any height warning, so there's no height warning. And then it repeats back down to this state where it's constantly reading the soil moisture. So in other words, it will go around this loop. As long as there's enough water in the butt, it will continue to keep the pump on. If, however, it checks the height and the height is less than 10, then it goes to a state called pump alert. So pump alert will switch off the pump, so pump is equal to 0, and then it turns on height warning, and then it goes back around the loop again. There's also another state here that says, well, the soil is wet, so it's going to do nothing, so it turns the pump off. So if the soil is wet, then it goes into this state where the pump is set to off, and then it goes back into the loop where it's constantly reading the soil moisture. So let's see this in action. So what I'm going to do, I'm going to run this in real time. And it should initialize the water butt level to be 0. So water butt height is 0. Let me switch on some rain. So the rain starts to flow, and the water butt height should start to increase. There is a bit of a lag in this system. There we go. Okay, so now there's water in the water butt. Okay, and currently the soil is wet, so it doesn't need watering, and that's feeding into the state system, so it shouldn't turn on the pump. But when the soil is not wet, we'll switch that off. So now the soil is dry, so it goes into the state controller and it turns the pump on. So the pump is on, and then the water height in the butt starts to reduce. As it reduces, this height is feeding back into the state controller, and you'll see eventually if it gets below a certain value, then there will be a height warning comes on, and also the pump switches off. So that's just a brief introduction into the state system of the irrigation system that we have.